Good morning, students.
Good morning, sir.
Is my voice audible? Somebody, please switch off your microphone. Is my voice okay now? Okay, good morning, students.
Good morning, sir.
Is my voice clear to you?
Yes, sir.
Yes, sir.
Okay, students. So, is my PPT visible to you, students?
Yes, sir.
Okay, thank you. So, sorry for the dilemma. Here I'm getting some problem with my microphone. Okay. So, is my voice audible to you? Somebody please respond.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, thank you. So last class we have studied about the hardware structure of adder as well as subtractor circuit by using sign magnitude representation or data. So today we are going to study about what is the flow chart of that hardware implementation. Okay. So from this we are going to complete that first topic. Okay. Using sign magnitude, addition and subtraction. See here, students, we have studied about hardware implementation of adder and subtractor circuit by using sign magnitude representation. See here, students, here this is the flow chart of sign magnitude representation to implement hardware. See here, students, in this flow chart, what we are going to do, generally there are very few tasks are different. First one is initialization or start. See here, can you observe this symbol? See here, like this. This is generally which says start or stop operation or some initializations also. Initialization means initially what are the necessary steps you have to consider. Okay. So whenever in this flow chart, if you see this kind of symbol or box, okay, rounded corners. So this is the start the operation or stop the operation, or you are going to initialize the parameters initially. Then if you see here, this is octagon, okay? See here. So this one generally we are going to do some particular operation. Specifically, it is different. So generally we use all operations for rectangle. And if you want to take any kind of decision, okay, you just take this one, okay? See here. If you want to, is there any conditional instructions, okay, you are going to take this symbol, okay? So rectangle, generally we are going to do some operations. So move the data from one location to another location, and you have to do some operation. Again, do the data to another register, move the data to another register. So these are repeatedly used here, and you need to use arrows in order to flow if what happens. So generally we use arrows from this to next stage. So there is a previous stage and there is a present stage and next stage. So this data, if this is 0, we are going to do this operation like that. So here there is a sequence of operations which takes place to carry out this addition and subtraction operation, students. See here, this is exclusively to implement hardware. So in sign magnitude representation, okay, so how you are going to implement a hardware, okay? See, we have studied the algorithms addition and subtraction separately. See students, initially in addition, what you are going to do, you need to load ASN to A. So whatever the content which are there, that you need to load into A and add into B. So there are two different numbers. One is called A, which is called ASN, and B is addend. So initially you have to load the data to A and B for addition. Similarly, so this is called initialization. Similarly, in subtraction operation also, so there are two numbers. So A and B. A in subtraction, A means mini end and B means subtrahend. So there are two numbers in subtraction, two numbers in addition. Okay, both we just labeled as A and B. But in the case of subtraction, A means mini end. So first letter, whatever. Suppose 2 minus 3, this comes under the mini end A, and this comes under the subtrahend. Second number should be, so whichever subtracted from the, so subtracted from mini end. Okay, this is mini end, this is subtrahend. Similarly, in addition also, so ASCEND and addend, there are two numbers that we have to remember. And here what happens, first step, the contents are loaded to A and B, whether it is subtraction, whether it is addition. So the values of A and B are loaded in the registers. That is initialization, students. Immediately what happens, this is sign magnitude. Depending upon the sign, we have studied, see here the table. Depending upon the sign, we are going to decide what operation takes place. Have you understood this, students? First step is to load the contents. Immediately, depending upon the signs of A and B. Okay, suppose let us take, so you need to observe the both subtraction operation as well as addition operation simultaneously, because this circuit is common for both the addition and subtraction. Suppose if, let us say AB, okay, I am giving you a simple notation to identify the signs. So 1 means plus, let us say 0 means minus. So let us say first one 1 1 1 0 0 1 0 0. Students, have you understood this? Students, please respond. Students,
Yes, sir.
I just initialized 1 means plus, 0 means minus. So first of all, I am talking about addition. So based on the signs of A and B, we are going to do some operation. Suppose if signs of A and B are identical, you need to add A and B and attach the sign of A to the result. Okay, do you understand this? If
Yes,
A
sir.
and B are are having different signs, so immediately you have to do the comparison. So in comparison, if A is greater than B, okay, you need to do A minus B. So there is a procedure algorithm. Similarly, in subtraction also, you need to compare the signs first. Then you have to do addition or subtraction, whatever. So by comparing this, I am exclusively used exclusive OR gate. Students, please respond. How exclusive OR gate gives the, if both inputs are having same sign or different sign. Suppose we are, if you apply signs to the exclusive OR gate, see here, suppose if it is 0, 0, what is output, students? Exclusive OR gate?
0.
0. If it is 1, 1, what is output, students, for exclusive OR gate?
0.
1, 1.
0.
0. That means, see here, we just applied two set of inputs. 0, 0, 1's output is 0. 1, 1 inputs, output is 0. So you need to understand, if we apply the signs of A and B to the inputs of exclusive OR gate, you are getting 0 output when both signs are same. Understand, students? As I told you, 1 means plus, 0 means minus. So if you apply minus, 0, 0 means minus minus sign, A having minus, B having minus, output is 0. Similarly, if you apply 1, 1, 1 means plus, as we initialized. So 1 means plus, plus, 1, 1 applied to exclusive OR gate, you are getting 0 output. So if exclusive OR gate output is 0 means both input signs are same. Okay, students? Students, have you understood this?
Yes, sir.
Suppose if you apply 1, 0, what is output?
1.
1.
0, 1, what is output?
1.
1.
So if both inputs are having different signs, 1 means plus, 0 means minus. So 1, 0, you are getting 1 output. So 0, 1, you are getting 1 output. That means if exclusive OR gate output is 1 means the inputs which are whether addition or subtraction, the inputs are different signs. So have you understood this, students? So by using a simple 2-input exclusive OR gate, the inputs for this exclusive OR gates are sign bit only, not the contents. You have to apply the sign bit. So in sign magnitude representation, suppose 2 means 0, 0, 1, 0. So this is sign bit. Okay. Again, 3 means 0, 0, 1, 1. This one is sign bit. So here both are plus 2, plus 3. So if 0, 0 applied to the exclusive OR gate, exclusive OR gate output is 0, so that these two are having same signs. Understand, students? Students, have you understood this? How you are going to decide the signs are equal or different? Students,
Yes.
please respond. Have you understood? Okay. See here. In subtraction, the next step is A and B are applied to. So signs of A and B are applied to. See here. Observe here. We are going to apply AS and BS. A and B are anyway contents. A having the contents of input, B having the contents actual magnitude. This is magnitude. This one is magnitude of B. But AS and BS exclusively sign bits. So AS exclusive OR of BS, here also in subtraction, AS exclusive OR of BS. So suppose, students, when they add, if you come to add, this is exclusive OR operation we are doing here. Next step, if output is 0, what happens, students? What you understood output 0 means?
A equals to B.
Yes, signs AS is equal to BS. So signs of A and B are same because exclusive OR operation. Then what happens? What we are going to do, students, in addition, you need to do A plus B. Is it right?
Yes, sir.
Signs of A and B are same. In algorithm, in addition algorithm, you need to do addition and attach the sign of A. So if signs of, you see here, is equal to 0 means both are same signs, then immediately you need to do, what is next step, students? A plus B. You would do addition and the result is stored in E and A. See here. So we have seen, see here, students, the result, see here, after doing addition, parallel adder, so the carry is stored in E and the result is stored in A register. So that's why, see here, EA means register. A is one register, accumulator, you know. E is the single bit flip-flop which is going to store the carry. Understand, students?
Yes, sir.
So this is one point in addition. In the similar way, students, see here, if AS signs of A and B are not equal, means the output of exclusive OR gate gives 1. Understand? There
Yes,
are
sir.
possibilities. First possibility is 0. 0 means equal. We need to do addition. You will get answer. Simple. Okay? The task is very simple. But whereas if AS and BS signs are not equal, whether it is 1, 0 or 0, 1, that means immediately you need to do a subtraction. Whether it is, so I already told you A minus B, B minus A is going to achieve by doing only A plus B complement plus 1. Understand, students?
Yes,
Here,
sir.
this is purely 2's complement subtraction. So in 2's complement, sign is going to adjust based on the magnitudes of A and B. If A is greater, B is less, you are going to get the carry after adding A plus B complement plus 1, end around carry. Simply you need to neglect the carry, put the positive sign to the result. If B is greater magnitude, A is smaller magnitude, in that case, you are not going to get any carry after adding A plus B complement plus 1. In that case, you need to take the complement of the result after adding this one, you are getting some results. So if you don't get any carry means, which is a negative number. So you have to take the complement of that result, put minus sign in front of it. So do you know this, students? I already explained, this is very important. Okay. So if these are not equal, what happens? You need to do subtraction. So subtraction is carried out by taking 2's complement of negative number. So A plus B complement plus 1. So this is A minus B, students. So see here, if these are signs are not equal, see here, signs are not equal. So output of the XOR gate is 1. So you are going to do A minus B. Then you need to, so after doing this 2's complement subtraction, the big thing is you need to adjust the sign. That's why this whole thing is going to adjust the sign. I will explain you. Okay, students? After doing this A plus B complement plus 1, what we are going to do? If carry is occurred, if end around carry is occurred, what happens? Simply, you need to exclude the carry, ignore the carry, and the result is positive. Okay, students?
Yes, sir.
That's why the next step is to adjust the sign that we will discuss. So have you understood this add side operation, students?
Yes, sir.
Coming to the subtraction, the same thing, see A, B. First of all, you need to compare the signs based on these students. Okay, here 0, here 1, here 1, here 0. So this is exclusive OR operation, students. Okay. Suppose if this is quite opposite. If signs of the A and B are different, you need to do addition, students. Okay.
Yes, sir.
So if signs of A and B are different, we are going to give the inputs of signs AS, BS to the exclusive OR gate. If it is 1 means inputs are different, 1, 0 or 0, 1. In that case, you need to do the addition. See here, in that case, so we are going to, so see here, AS is not equal to BS, so that we get the 1 here. In that case, I simply do the addition. Okay, understand, students? And whatever, yes. After addition, what happens? EA, this is carry, store, if any carry is there, the carry is stored in temporary register E, temporary single bit register, and accumulator contains the magnitude. So after that, finally, this E, contents of E is moved to add overflow flip-flop. That is permanent. Okay, see here, that is only thing we need to do. This carry is transferred to AVF, add overflow flip-flop. Then that is, task is completed, over. Okay, you are getting the magnitude in A and the carry in AVF. Suppose if both are equal, what happens, students, in subtraction?
Subtraction.
So in subtraction, both are identical means if the exclusive OR gate output is 0 means AS, BS are same, 0, 0 or 1, 1. In that case, you need to do a subtraction, A minus B or B minus A. So as I told you, a minus b and b minus a. So that is simply a 2's complement subtraction. Okay. So here we are doing a minus b by taking a plus b complement plus 1. So the result is stored in a. So a is magnitude of that addition and e is if any carry is there. So here initially this AVF is 0 in here. Okay. Then students, have you understood up to here?
Yes, sir.
Very simple, students. This is simple as we have discussed in algorithm and hardware implementation. I am talking about how you are going to implement the step-by-step procedure. This is a flow chart. Okay. So addition, at the addition, simply we add two numbers. Okay. Both cases. In the case of addition, both signs are same. You need to add. In the case of subtraction, both are having different signs. You need to add. Okay. So as I told you in the table, even though these are addition and subtraction, we are having common operations, only addition and subtraction. That's all. Even though in the table you are having a minus b, b minus a, and a minus b attached sign. So all those are achieved by using only simple procedure. Understand? We need basically a adder. We need basically a 2's complement subtractor. Understand? So after doing this subtraction, the biggest problem is how to add a sign. Suppose if a is greater, b is smaller. Okay. For example, in 2's complement, suppose 3 minus 2. What is the result, students?
1.
1.
Plus.
This is plus.
Yes, sir.
Okay. So what you are going to do? So mini end is 3 here. Here subtrahend is 2. So you are going to do 3 plus, take the 2's complement of 2 plus 1. In that case, you are going to get the carry here. After adding this, you surely get the carry. Understand? So then you need to exclude the carry. See here, after adding, see here. Here there is a E means carry. If any carry is there, E means which is temporary storage flip-flop for carry. So after addition, we are going to check the this flip-flop. If flip-flop contains 0 means no carry. If flip-flop contains 1 means what is the in 2's complement subtraction? If carry is 1 means what we are going to do, students? Simply, which is A is greater, B is smaller. Understand, students?
Yes, sir.
A is greater, B is smaller. We are going to get the carry. So what we are going to do? Simply exclude this. So simply after what happens if A is the magnitude equal to 0 means, suppose if magnitude is 0, sign bit must be 0. If this is not equal to 0 means directly this is the answer. Okay, result is stored in A and AS. So both are having 0. AS is 0, which is positive. Okay, students. And this is the first case. Second case, if the carry register contains 0, no carry. No carry means probably B is greater, A is smaller. That means A is less than B. Suppose you are going to do 2 minus 3. In this case, you are not going to get the carry. Carry is 0. So in that case, what you are going to do? You need to take the again complement of 2's complement of results, and you need to attach minus sign. That means, see here, how you are going to get the minus sign, students? How you are going to get the minus sign? So before that, what you are going to do? You need to first take the 2's complement result, 2's complement of results. So how you are going to get the 2's complement of results? Result is stored in A register. How to get the 2's complement of results? Take the A complement plus 1. This is the 2's complement of A. Students, do you know this?
Yes, sir.
Students, so after this addition, A plus B complement plus C, 2's complement subtraction. So result is 0 means whatever the content which is there in A, which is not the actual results, that is the negative number. So you have to take the complement of A and attach the sign. Sign means AS should be 1. Okay. So how to get the 2's complement of A? First take the complement of A. So A complement is loaded into A register. Then add 1. So A plus 1 is, do the A plus 1 increment by 1, and the result is stored in A register. So these are the internal features which are there in accumulator, students. With the accumulator, as I told you, we are going to do many things, many operations in accumulator only. So only this internal register, special purpose register, is accumulator. It is having all the logical operations. So you are going to do the A complement and the rest must be stored in A. Again, after that, you are going to increment A by 1. So now this is completely after doing this, A is stored to A complement plus 1. Okay. So now this is simply a 2's complement of A. Again, see here, AS is stored to AS. So which is negative number. Understand, students? This is purely a negative number. AS actually loaded by 1. So AS is stored by initially there is a 1 AS in this number. So here AS is loaded by 1 and A is taking the 2's complement of A. So A having the 2's complement of A. Now the result should be minus of 2's complement of A. So now after doing this, so the results are stored in A and AS, even though whether it is negative number results, whether it is positive number, in the subtraction case, whether it is positive, whereas addition, you are getting magnitude and sign. So this is the complete flow chart for hardware implementation of sign, magnitude, addition as well as subtraction, students. So have you understood, students? Do you have any doubt regarding this? Please ask me, because this is very important. You need to understand this flow chart. Please, do you have any doubts regarding this, students? Students, please respond.
సార్ ఒకటి ఎగ్జాంపుల్ గా సబ్ట్రాక్షన్ చేసి చూపించరా.
Okay, very good. So you want subtraction, whether it is okay. I'm taking two cases. If I'm taking 4 minus 2, okay, students, 4 minus 2. So in sign, actually before going to do this, what is the sign magnitude representation? Actually minus 2 power n minus 1 minus 1 to plus 2 power n minus 1 minus 1. This is the range of numbers which are going to represent in 2's complement. Understand? Suppose if I am taking n is equal to 4, students, what is the least number? Minus 2 power 4 minus 1 minus 1. That means 2 plus 2 power n minus 1 minus 1. Okay. So minus 2 power 3, 8. So minus 7 to plus 7. Okay, students. So if you take n is equal to 4, students, n is equal to 4, you are going to represent plus 7 to minus 7. Suppose I want to take 4 means 0, 1, 0, 0. Okay. Minus 2 means what is the actual plus 2? 0, 0, 1, 0. Take the 2's complement of this. Okay. So 1, 1, 0, 1. Take 1, 1, 1, 1, 0. So 1, 1, 1, 0 is the minus 2 representation, students. Understand, students? Have you understood this? So we have already studied these representations. So anyway, for your understanding, I am taking, for example, 4 minus 2, first case. So simply 0, 1, 0, 0. Okay. What is 2's complement of, what is 2 here? 0, 0, 1, 0. What is the 2's complement? 1, 1, 1. See here, 1, 1, 1, 0. I already find this 2's complement of 2. So minus 2 you can represent 1, 1, 1, 0. So this minus 2 you can write 4 plus minus 2. So minus 2 means 2's complement of 2 you can represent. So 2 means 0, 0, 1, 0. I can take the 1's complement 0, 0, 1, 1, 0, 1, add 1, 1, 0, 1, 1, 1. So now add these, students. What is the answer? 0 here.
0.
Here.
1.
1 here. 1, 0. Here. 1, 0. So do you get carry here, students?
Yes, sir.
You got carry. So in that case, carry is 1 means what we are going to do? Simply A is greater, B is less. So A is 4, B is 2. Understand? The result is not 0. Result is not 0. So result is simply A, 2. Understand, students? Result is 2. And out of this 4, 0, 0, 1, 0, this is sign bit. Understand? So sign bit is 0. See, result is not equal to 0, my kada. See here. A, check the A. If A is equal to 0, then you have to make the A is 0. That is not needed here. If A is not equal to 0, result is 2. So 2 means 0, 0, 1, 0. What is sign bit here, students?
2.
0 means plus. So the result is plus 2. So do you understand this?
Yes,
Yes,
sir.
sir.
Suppose I am taking second case 4 minus 2. I am taking second case 4 minus 2. So case 2. So A is 2, B is 2 minus 4. You need to do 2 minus 4, for example. Okay. A is 2, B is 4. So here, what is 2 here? Positive number. 0, 0, 1,
0.
which is A. And B is, take the 4. 0, 1, 0, 0. This is the actual plus 4. Take the 2's complement of 4. So take the first 1's complement. 1, 0, 1, 1. Okay. Add 1. 1, 0, 1, 0, 1, 1. Okay. So 2's complement of 4 is 1, 1, 0, 0, students. Understand? So
Yes,
now
sir.
we add 2. Now what is this here? Add these 2. So 0, 1, 1, 1.
1, 1.
So is there any carry occurred here?
No,
No
sir.
carry. See here, carry is 0. No carry. So no carry means this is a negative number. Here A is less, B is greater. A is less, B is greater. So in that case, what you have to do? You need to take the 2's complement of the result. So result is 1, 1, 1, 0. 2's complement means I am taking 0, 0, 0, 1. Again, this is 1's complement, add 1. So 1 means 1, 0. Okay, 1, 0, 0. Understand, students? Students, have you understood this?
Yes,
So
sir.
this is 2. And you need to load 1 here. AS must be 1. Okay, students? The result is 2. And the sign bit must be 1. Sign bit is this. This must be changed to 1 here, students. Understand? The result should be minus 2. So as we know, if the carry is not occurred here, what we are going to do? The result is negative number. So negative number means you need to take the again 2's complement of the results. So 2's complement of this is 2. So you need to place minus so that the sign bit must be loaded to 1 here. Okay. So have you understood these 2 examples, students?
Yes, sir.
Yes, sir.
Any doubts, ma, please? Because this is very simple. A single circuit is going to execute both addition as well as subtraction, students. So there are 2 basic things. Again, these 2, can you observe here? These 2 same. Because here only A plus B, here A plus complement of B plus 1. That means here only A plus B plus 0. Here A plus B complement plus 1. So as I explained you in the hardware diagram, see here, students, if you want to do addition, simply M is equal to 0. M is equal to 0 means you are going to achieve A plus B plus 0 because M is 0, 0 for the one exclusive OR gate. Here complementary means we are applying M, this signal to the all the one input for all the exclusive OR gates. Another input is B. So whatever the input, that is as it easily gives as output. So in that case, B directly connected to the parallel adder. So you are going to get A plus B plus 0 because the mode is 0, then addition. Understand, students? Mode is
Yes.
0 addition. Suppose mode equal to 1 means if one input of the exclusive OR gate is 1 means the output is complement of other input. So in that case, you are going to get A plus B complement plus 1. Understand? So in hardware implementation, we are using a single parallel adder in order to execute both addition as well as subtraction. So even though in this flow chart we are represented separately, These two tasks are going to implement in single block. Understand, students?
Yes, sir.
Yes, sir.
So we need only a parallel adder in order to achieve with a plus b or a plus b complement plus 1. So here carry is 0, here carry is 1. So we use full adders, multi-bit addition, parallel adders. So that you need to understand in hardware. So understand, students, this is very important to illustrate or to predict how you are going to implement in hardware. So this is complete. The complete operation lies in this flowchart, students. If you understand this, okay, what we have learned about separately addition algorithm, subtraction algorithm, then we have combined both in a table. So all these are carried out in this flowchart. So all points are covered here. Okay. So if you remember or if you understand this flowchart, no need to by heart anything. Okay. Understand, students? So everything you have to remember in a logical way. So I hope you understand this concept. And can I move to next topic, students? So
Yes,
it takes
sir.
almost 2 classes to complete this addition and subtraction by using sign magnitude representation only. So, and second method is how you are going to do addition and subtraction by using 2's complement method, 2's complement data. Students, even though in previous sign magnitude representation also, we are doing a subtraction by using 2's complement method only. But what is the difference there? There are separate registers to maintain the sign bits. There is A register, you have AS. So A register contains the magnitude, AS register, single bit register contains the sign of that A. Similarly, B register contains the magnitude and the BS register contains the sign. So in sign magnitude, you need to have separate components to maintain the sign bits. But whereas in 2's complement is very simple, most of the computers, they use 2's complement representation in order to carry out the subtraction as well as addition. Okay, students, let us do very simple. We don't separately represent the sign bits here. Whatever in 2's complement, we learn the 2's complement. 2's complement means negative numbers must be 2 power n minus 1 minus 2 power n minus 1 2 plus 2 power n minus 1 minus 1. Suppose if n is equal to 4, for example. So minus 2 power 3 means minus 8 to plus 7. You can, so suppose if n is equal to 4, in 2's complement representation, you can able to represent the range of numbers from minus 8 to plus 7. Okay, students. So we already studied this. Similar way, based on n, you can have different range of numbers. Okay. And what is the actual fundamental representation, students? You simply remember, if sign bit, here also all the positive numbers can be represented directly by putting the sign bit 0, because in 2's complement, again, positive numbers can be represented as sign magnitude. That means sign bit should be 0. Only negative numbers can be represented in 2's complement. Okay, students, have you understood this? Students, are you there?
Repeat once.
Have you, are you getting my, I mean, is my voice audible to you?
Yes, sir.
See, in 2's complement, positive numbers can be directly represented as we represented in sign magnitude representation. So simply, suppose 2 means, plus 2 means, using 4-bit, 0, 0, 1, 0. How you are going to say this is plus? You just search for the sign bit, most significant bit. This 0 means plus 2. If you are going to represent plus 6, 0, 1, 1, 0, that equal to plus 6. The problem here is only with negative numbers. Negative numbers are represented in 2's complement. Suppose the same 2, if you want to represent minus 2, first take the plus 2 value, 0, 0, 1, 0. Take the 2's complement of this value, 1, 1, 0, 1. Add 1 here, 1, 1, 1, 0. So 2's complement, I mean minus 2 can be represented in 1, 1, 1, 0 here. Have you understood, students? So
Yes, sir.
simply in all the minus numbers, the MSB bit should be 1. You can check any number. All the negative numbers, the most significant bit should be 1 always, even though it is 2's complement. Understand, students? So MSB bit 1 means by default this is a negative number in 2's complement form. Okay? So these are the actual representations of 2's complement. How you are going to do here, students? So we already know, because we use this 2's complement in sign magnet representation also. So you want to do addition. See, there are BR and AC. AC means accumulator register, okay, and BR means B register. Okay, don't confuse. BR means B register. The bit length may be 8-bit, 16-bit, 32-bit, depending upon the hardware requirement. So what first task is, if you want to add A and B, A plus B, what you are going to do directly, you can take A from here. So A plus B, the result is stored in A plus AC plus BR. The result is stored in AC, first step. And here we are not mentioning specifically the carry register. The carry register is part of the parallel adder, students. Inside there is a carry register, okay? And one more thing is here, overflow. What is overflow here, students? Suppose you are going to add 2 bits which is having the bit length is n. The addition itself, the bit length is n plus 1 means, so the bit length n, suppose you want to add 2 4-bit numbers, okay? Suppose the result, you are after adding, the result may be 5-bit. In that case, this comes under the overflow. So the existed bit length cannot be sufficient to represent the result. In that case, overflow bit must be 1. Okay. So later, the user must be do the some operations in order to get the correct results. So overflow occur means you are getting wrong results. Whatever the result which is shown, which are not correct. Okay. So for example, students, if you want to see here in 2's complement, if you want to add plus 7 plus 1, what is the result, students? Somebody
Plus
say?
8. Plus 8.
If plus 8 is there in this 4-bit representation, somebody please.
No, sir.
No.
Do you get my point?
Yes, sir.
See, plus 7 is there in this representation because
Yes, sir.
if n is equal to 4, the range of numbers from minus 8 to plus 7. That means 0, 1, 2, 3, 4, 5, 6, 7. Okay, minus 8, minus 7, and so on. So minus 1. So if you want to add plus 7 means, see, 0, 1, 1, 1 plus 1 means 0, 0, 0, 1. The result should be 1, 0, 0, 0. Actually, 1, 0, 0 is, see, this is not the 2's complement in this range. The sum must be 8. So 8 means you need to exclude one sign bit. So out of 4-bit students, one sign bit must be excluded. See here, n minus 1. One sign bit must be excluded. So in this case, you need to represent the actual results 4 bits. This is n minus 1. And one more bit is there, which is sign bit. So because of this, so there is a overflow. Understand, students? So
Yes, sir.
the result should be 0, 0, 0. Understand in this case? Because
Yes, sir.
only 3 bits for magnitude, 1 bit for sign here. So in plus 7 plus 1 means 8. So this is actually 4 bits for result, but only 3 bits for result for the results. 1 is for sign representation. So there are some cases for this overflow. What happens after getting this overflow? You need to adjust the results. That is carried out. There is a separate algorithms. Okay. Anyway, that is not in our scope. Now you need to understand there is a case the overflow occur. Understand, students?
Yes, sir.
And one more thing, how you are going to identify overflow after addition? You are having 4-bit to 4-bit addition. Suppose 1 1 1 1 1 1 1 like that. Suppose if there is any carry of last 2-bit combinations, if carry of last 2-bit combinations, take the carry of this and apply it to exclusive OR gate. If this is 0, no overflow. If this is 1, there is a overflow in 2's complement. That is very simple logic in order to find out the overflow occur. Okay, students? And this is simple addition. Suppose you want to carry out subtraction, which is AC is loaded with AC plus complement of B register plus 1, which is loaded with AC again. So how you are going to take the complement here? So take the BR complement. Okay. So complement gives the BR complement, and there is a plus, you need to take the 1. Okay, students, this is very simple complement. That's why. So if you have studied already sign magnitude representation also, so you compare these two. This is very simple. We are taking the part of the operation, sign magnitude. Okay, so let us take 2 algorithms quickly. Okay, you want to do addition, students. What we are going to do simply, I am going to take the first agent must be loaded. So the contents must be loaded to accumulator AC, and the addend must be loaded to BR. These two are the register, students. And after this, so this is the initialization. This is initialization. So after initializing, that means, so the whatever the, suppose I am taking +4 is loaded to AC. So +2, I want to add +2 is loaded to BR. So now AC contains +4, that means 0, 1, 0, 0. Now BR contains 0, 0, 1, 0. That is the meaning of this initialization. We need to load the data to AC register as well as BR register. After loading the data, you need to do addition in addition algorithm in 2's complement representation. What you are going to do? Simply add AC and contents of AC and BR. The result must be stored in accumulator again. So simply this is A plus B. After doing A plus B, the result of this must be stored in A. Okay, students? And and if there is any carry, that must be stored in E register. So that is not shown here, which is part of addition only. Okay, students? Addition means which is sum and carry. So that we are not mentioning separately here. And overflow. Suppose if there is any overflow occur after, so the last 2 additions, carries must be applied to exclusive OR gate. If exclusive OR gate gives the 0 means no overflow, 1 means overflow, students. Okay, as overflow means you have to do the adjustment of the result after doing addition. That is very important if overflow is occurred. So after addition, then simply end the operation. Very simple. See here, only one step, one active step to add. But whereas if you observe this, see here, you need to do this much sign magnitude representation. Understand, students? Students?
Yes, sir.
So sign magnitude is very simple, but with respect to, by users. But if you want to implement, that is very complex. But 2's complement is very easy for the computers. Understand, students? And coming to the subtraction, you need to load the data contents to the AC register, minuend and subtrahend to BR. Then, so AC minus BR must be carried out by taking 2's complement of BR. What is 2's complement of BR? We are taking AC, which is AC, and minus BR means taking the 2's complement of BR complement plus 1. So this is the 2's complement of BR and added to the mini end. So after adding, the result is stored to accumulator. If there is any overflow, that overflow bit must be active. Okay. So then
Yes,
end the operation. So this is the algorithm for addition and subtraction with sign 2's complement representation of the numbers. So do you have any doubts, students, regarding this?
No, sir.
So with this, we completed the first topic, which is addition and subtraction. So in addition and subtraction, you have 2 methods. First one is sign magnitude addition and subtraction, and second one is 2's complement addition and subtraction. So we have discussed the algorithms and the hardware implementation and the flowchart for sign magnitude as well as 2's complement also. So So the same algorithm, simply addition, add directly, and the subtract negative subtraction means you need to take you need to get the subtraction by adding the numbers. How you are going to add? Simply you take the 2's complement of negative number and add to the accumulator. Okay, students. So later, how you are going to decide sign here? That is also not mentioning here, but by default, sign if the carry is occurred, end around carry. Suppose carry is 1, so exclude carry. Result is positive. Understand, students?
Yes, sir.
If carry is equal to 0, then so result must be negative. Take the 2's complement of result. Understand, students?
Yes, sir.
This adjustment is very important. This is by default 2's complement. So how you are going to? So here, can you observe there is no separate sign bit representations. In 2's complement, whatever the complete bit can be added along with sign bit. But in sign magnitude, sign bits are not added. Only the magnitudes are added. Signs are later adjusted. Understand, students? But here we are adding AC and BR registers with sign bits. Okay, students? So that is the very simple operations which are there in 2's complement, addition and subtraction. So do you have any doubts, students?
No, sir.
Okay, thank you, Amma.
Thank you, sir.